Hi everyone, I am K.Harshith. In my previous video, we have learnt about Cyclo Alkenes in the group of hydrocarbons. So today we will go through the concept of Cyclo Alkenes. Before going into Cyclo Alkenes, let us first revise about Cyclo Alkenes and then we will go into Cyclo Alkenes. First, cyclo means ring structure. Cycler or a ring structure. So this is a cycle. We have seen that all these cyclohydrocarbons start with the number of carbon atoms 3. They start with the number of carbon atoms as 3, because with 2 and 1 we cannot form a cycle or a closed structure. Okay, only with 3, from 3 only making of the structure, cycle or a closed structure is possible. So we have seen that cycloalkanes means all are single bonds, and then the IUPAC name of that of the particular hydrocarbon will be cyclo, and then whatever it is like cyclopropane, cyclobutane or cyclopentane, like that it will be. And we have also seen what's the general formula of cyclo alkenes. CnH2n. So cycloalkanes general formula is CnH2n, and they would be having a name like cyclopropane or cyclobutane. Like this they would be having the names we have seen. So this is our cycloalkanes that we have learned. Now let us see about what we have in cycloalkenes. So cycloalkenes, same as we had for alkane, alkene, alkynes, even we would be having the same for cycloalkenes also, because cyclo means again cycle. Alkene means a double bond with one double bond, at least one double bond between two carbon atoms. So I said already, cyclos always start with n is equals to 3. So I am arranging 3 carbon atoms like this, and when it is alkene, so a double bond here, and then a single bond, This is the structure how we draw cycloalkenes. And then this has 2, so more 2 to satisfy tetravalency. This has 3, so more 1. This has 3, more 1. So this is the first member of cycloalkane series, which is cyclopropene. So now next let us see. Let us try to derive the formula on our own by seeing the structures. So what is this formula now? C3H1234, C3H4. N is equals to 3, we got C3H4. Okay. Now let us see for N is equals to 4. N is equals to 4. Carbon atoms should be arranged closed manner. So I already said in my previous video, whenever you are drawing the structures for cycloalkanes, and if you are taking the number 4, 5, then go according to their shapes. Like if it's a 4, then draw a rectangle or a square. If it's 5, a pentagon. If it's a 6, it's a hexagon, like that. So N is equals to 4 carbon atoms, one it's an alkene, so one double bond between carbon and carbon atom. Rest here 2 more hydrogens. Here 2 more hydrogens. Here 1 hydrogen. Here 1 hydrogen. This is the structure for what? Cyclobutene. This is the structure for cyclobutene. Now how we are writing it? C4 1 2 3 4 5 6, C4H6. Yes, we got the general formula as C4H6. So we got for N is equals to 4, C4H6. Last we will do for N is equals to 5, and then we will see that we are able to derive a formula. So when N is equals to 5, So when n is equals to 5, How are we getting the structure? C's will be arranged in a pentagonal manner. Okay, C's would be arranged in this manner. So, oh wait a second. So I'm drawing it here as the reflection is falling here. I'm drawing here. When n is equals to 5. So how are we arranging the carbon atoms in a pentagonal manner? And because it's an alkene, we are putting one double bond here. I'm always advising to keep double bond for the base. Whatever you are drawing the structure, for the base you put a double bond, so that you will not be confused. So this is the structure of cyclopentene. Now let us adjust hydrogens here. 2 hydrogens here, 2 hydrogens here, and here one, here one. Now for this C5H 1, 2, 3, 4, 5, 6, 7, 8. C5H here. So for n is equals to 3, we are getting C4H. C3H4 we are getting. For n is equals to 4, C4H6. For n is equals to 5, C5H8. Now what can be the general formula? Can the general formula be CnH2n or CnH2n plus 1 or CnH2n minus 2, or here plus 2? Out of these three, which formula can be taken so that this is satisfying all the three? CnH2n, Cn means 3, C3, H2, 3 is a 6, but we are adding 4. So this is not the correct formula. Next, CnH2n plus 2, Cn, C3, okay, right. H2n, 2, 4 2s are 8, 9, 10, no. C2, 3 are 6, 7, 8, no. Even this is also not possible. Coming to this, Cn, C3, okay. 2 3s are 6, minus 4, minus 2, we are getting 4. So this is applicable. Now let us even check for this. Cn is there, so 4, C4. H, 2 4s are 8 minus 2, 6. Yes, it's applicable. Here also, 2 5s are 10 minus 2, 8. So what can we conclude? We can say that cycloalkenes have a general formula of CnH2n minus 2. CnH2n minus 2. So we have seen how to derive a general formula or a structural formula, and then we have also seen 3 different alkenes, cycloalkenes. The name of this would be cyclopentene. Okay, so we have seen the structures. Now let us see the electronic dot structure. For out of this, for any one structure we will see the electronic dot structure. For any n is equals to 3, 4 or 5. We will see for n is equals to 4 how the electronic dot structure will be. So C4H6 I am drawing from the from this formula, from the structural formula only. I am trying to draw the electronic dot structure. One carbon, so I am placing carbons as it is. Then each bond, now carbon, this carbon is having one hydrogen. So each carbon, first I am placing 4 electrons. We put it here, okay. 4, and then 1, 2, 3, 4, and then for this 1, 2, 3, 4. Done. For carbon we have satisfied tetravalency. Now hydrogens, where you can find hydrogens? Here there is one hydrogen, here there is one hydrogen, okay. Here there is one hydrogen, here there is no hydrogen here. Here there is one hydrogen, here I am placing the hydrogen, and then here there is one hydrogen, here there is one hydrogen. So these are the hydrogen bonds. This is the hydrogen bonds. Now what about the bond of carbon? So here 1, 2, 3, 4, 5, 6, 7, 8. This carbon has got 8 electrons. This carbon 1, 2, 3, 4, 5, 6, 7, 8. And this has got 8 electrons. Now we are drawing for alkenes, right? So the electronic dot structure should contain a double bond. So a double bond means two pair of electrons. Now this carbon, two electrons are left here. So I am adding them here like this. Now it has become a double bond, and then for this carbon, if you see 1, 2, 3, 4, 5, 6, 7, 8. So this is the bond that we are getting for this carbon atom. Okay, and then for this 1, 2, 3, 4, 5, 6, 7, 8. For this, it's this one. It's a very confusing one. But yeah, if we draw it, it's a very interesting to draw electronic dot structures for these alkenes and alkane, alkynes, cyclo alkanes, cyclo alkanes, cyclo alkynes. It's very interesting and it's very joyful to draw the electronic dot structure. I hope you have understood the electronic dot structure. We are just trying to adjust each carbon atom with 8 electrons, and then the place where there are no hydrogens available, I have placed them here in this slot because it's alkene, so there should be double bond. Single bond means one pair of electron, double bond means two pair of electrons. Here this one pair is from carbon, one pair will be from hydrogen. But when there is a double bond, the two pairs will be from carbon and carbon. Like this, some mnemonics or some tricks can be, you can choose some tricks to remember the concepts easily. I hope you have understood the concept of cycloalkenes. Yes, the general formula goes with CnH2n minus 2. We have seen the structure of cyclopropene, butene, pentene, and then the electronic dot structure for cyclobutene. Yes, if you are having any doubts, please comment your doubts in the chat, in the comment box below. I will be replying to your doubts. Thank you so much.